And welcome to the Daily Space Weather. I'm your host, Dan, aka smAsho. Today we'll be talking about significant activity from Sunspot 2785. A larger sunspot has emerged on the southeastern limb. Solar Flare Watch and CME Watch are both in full effect. There is an increased chance of M-class flares and more as we see a quite large sunspot trailing Sunspot 2785 down here in the southeast. We've got some close-ups of that area as well as lots more data to cover. Check it out. A serious sunspot, the largest one I think we've seen so far in cycle 25, has just showed itself over the southeastern limb. Now, if you're wondering where the SDO is located, it's located actually somewhere around here, in between Earth and Lagrange point 1. We don't see any coronal mass ejections facing Earth or anything right now, but we'll be keeping an eye on it for you throughout the day. The 10.7 centimeter radial flux, a measurement of the outer solar corona, is up to 88. So, again, welcome to the Neo-Renaissance. Welcome to Solar Cycle 25. Solar minimum is officially over, and it's long since over. We just came out of geomagnetic storm conditions. We saw a minor geomagnetic storm, and we still do see some auroras, although they have toned down, as you can see on the screen there. And it was mainly caused by a major increase in solar wind, plus some direct solar activity. So here's our first HelioViewer movie of the day. A full disk view in 171 angstroms. All eyes on that lower left portion there, Sunspot 2785. I think the second sunspot's going to be named 2786. But I'm not sure if they're part of the same group or a separate group. It's not really that important because it has nothing to do with solar forecasting. Here's a close-up. Great view of that activity there. And we've got some other wavelengths and some even bigger zoom-ins here. Here's the 304 angstroms. By the way, we are streaming live to Twitch when we made this video. It's twitch.tv/smAsho. They have a great mobile app. It will notify you when we go live if you want to see us make the videos live. Sometimes we do so. And the more important the information is and the more time sensitive it is, the more likely we are to create a video as a live stream. Here's an extreme close-up. And I did not mean to put the Earth scale so close. But rather than redo it and wait, I wanted to put the video out, so here it is. Still a great view of Sunspot 2785 and possible Sunspot 2786. I think it's going to get a separate name. And we'll look at the magnetic fields toward the end of the video. Here's a composite of 94 and 131 angstroms. And both of these wavelengths take 10 images per minute instead of only 2. That's why we've included them. Some C-class flares came out of that region in the southeast. Last but not least, here's the 304 angstroms, which is probably the most spectacular in this most recent outbreak of activity from the local yellow dwarf. Some great views there of ionized helium emission spectra, 304 angstroms. Today's Smash Lights is going to be very short. I would invite all of our viewers to check out smashomash.com if you haven't done so. You can find all of our links there, social media links and so on. as well as our merch stores and our forum, smAsho.com, the official website of the Smash News Network. And today's featured product is the Are You Safe Yet mask. Are you safe yet? Are you wearing a mask right now while watching this video? Are you walking down the street by yourself staring at your phone with a mask on your face? Go out in public with our mask on your face and ask the people who are looking at you if they're safe yet. Ask them if they think that because you're wearing a mask that they're safe from COVID or safe period in any way. It's also got the website, smAsho.com, on the mask in gray, sort of a subdued relief there. Are you safe yet? A bunch of other stuff available also at our merch stores. I would invite you to check out the Sky Scholar video that was put up Saturday evening. It caused quite a stir and caused quite a lot of people to make comments and so on. Thanks for thinking of us while watching the Robitaille video, a 40-minute video debunking a 47 debunking video of Dr. Robitaille. It's fantastic. It's one of my favorite Sky Scholar videos ever. Check out the YouTube channel, Sky Scholar. Also check us out on BitChute. We're on Facebook. We're all over social media. Again, check out the links at smAsho.com. Now, we do have a small cosmology segment today. It's going to be pretty minor. We're not going to talk cosmic rays or random objects. Or thanks, Mary, for suggesting that R136A1 get named after me. Cheers. And if you don't follow our Twitter feed, you may not see this article right here. Unexpected orbits of ancient stars prompt a rethink of Milky Way evolution. Why is that? Well, it's because we don't expect low metallicity stars to be out here at the edge of the galactic disk around where the Earth is. But we see low metallicity stars out there, stars that have a very low amount of elements associated with them besides hydrogen and helium. Why is that significant? Well, because we should see older stars at the core of the galaxy, assuming that galaxies form the way that the standard model of cosmology and indeed solar evolution would dictate. So, as we've been saying for years, astrophysics and indeed the physical sciences are being rewritten. Here's an article from SciTech Daily about the unexpected orbits of ancient stars. Perhaps have yourself a read there. How come ancient stars seem to be orbiting the galactic core the same way as the sun? It's not understood in terms of cosmology and astrophysics, and things like the standard solar nebular model of the way solar systems and indeed galaxies form is called into question. Here's a quote. We've studied 475 of the stars and found that about 11% orbit in the almost flat plane that is the Milky Way's disk. They follow an almost circular path, very much like the sun. That was unexpected, so astronomers are going to have to rethink some of our basic ideas. Also, check out our community post if you haven't, and you can find that all at youtube.com/smashomash. We've linked the Robitaille video here in our community post, as well as the Professor Dave video. Professor Dave was kind enough to leave a comment. Haha, you will indeed watch the entire video? You'd be the first. I don't know if he means the Robitaille video or his own, but we did actually go a little bit in depth into this here, such as when Professor Dave thinks that Robitaille is suggesting that microwaves are reflecting off of the ocean, which is not something Robitaille said whatsoever. Microwaves aren't reflecting off of the ocean. Reflecting has almost nothing to do with the radiation emitted by the water in the oceans. And another quote from me, Dave is so incorrect on so many misconceptions about what was said by Robitaille, he's not even qualified to comment on them, much less, quote, debunk them. It took me about 45 seconds to note an error by Professor Dave. So go watch the videos, and again, youtube.com/smashomash. Please press like and subscribe, and tell your friends and foes, science noobs and science pros, about the channel. We're doing more to solar forecast than anybody else because we've got systems in place that nobody else is capable of comprehending, I don't think. So I figure if somebody else was able to do what we do on our videos, they would do it, but they don't. So you don't see other YouTube channels or NOAA or NASA or anybody else, as far as I know, on the planet able to and willing to solar forecast the way our channel does. Thanks to our patrons for being the true source of funding for the content. Please consider becoming a patron. It's patreon.com/smashomash. And we may provide you with some unexpected perks there. Stay tuned for more things, patrons. And there ends today's Cosmology segment. I thought it was a great story to cover. Let us know in the comments what you thought. And let's get back to some data, such as the real-time solar wind, shown here. And we saw the solar wind get all the way up to 640 kilometers a second or so there. That was about the peak. And now we see that coronal hole wind stream subsiding a little bit, still at significantly elevated levels, over 550 kilometers a second. Current solar wind density 6.5 protons per cubic centimeter. And there you can see the KP index over the past 3 days. We reached all the way up to a KP of 5 there, a mild geomagnetic storm condition. Here's the magnetohydrodynamic pressure. And this is part of the space weather modeling framework provided by University of Michigan. And that's 4 hours of data. Sadly, the ground magnetic perturbations have not been working. We'll only be able to show you a still image today. That's what's going on in the geospace. Significant pressure. So here is the magnetic perturbation map for the globe. And we don't see any animation there. I don't know what's going on with it. Leave us a comment if it's a browser issue, if you're able to load this data. We are not. But there's the best we can show you at this time at the Smash News Network. And here's the graph of the proton flux. We don't see any changes there. No coronal mass ejections on the way or currently striking the magnetosphere. Here's the solar flaring of the past 3 days, and there's that C-class flare. If you want to go look closer into that, it happened right at 17:30 Universal Time. 17:30 on yesterday, Sunday, November 22nd. Here's what's going on above my head. I like to use star charts. I like to face them to the south, and I like to use in-the-sky.org. I'm currently facing to the south, and my sofa faces to the south as well. And if you're up before dawn, you may see the third brightest object in the sky, Venus. Where will you be when Cygnus rises? Well, if you want to know, you can actually pull up a slider here, and you can actually animate it. And it looks like Deneb is going to rise where I'm located at about 6:45. Here's what's going on in the solar system. Here's where things will be in a week. Approaching another full moon on the 30th November. And here's the continued wild swings in the GOES magnetometer. Under normal conditions, you see more of a thing like this. The N's and M's mean midnight and noon time for the GOES 16 satellite. This GOES magnetometer is doing its magnetometer measurements at the ionosphere layer. Right at the F2 layer is where the GOES 16 endeavors to make its measurement. And we have forecasted these continued swings in the GOES magnetometer. And it's going to continue here. There still is a significant possibility of a coronal mass ejection and significant solar flares, possibly up to an M class or even higher, with that large pair of sunspots rotating into the Earth-facing view. Here's a polarity view of the current sheet. It's the top view ecliptic plane field plot, part of the National Sunspot Observatory, and this tells me that there is still significant possibility for those coronal mass ejections. So this is part of the reasoning that we use to do our forecasting here, and so we show our viewers daily. Hopefully we'll continue to do so, so please consider funding us, because the likelihood of these videos remaining free and publicly visible is dropping drastically quickly as the year trudges on. And I would expect us to remain in this North Pole current sheet here, shown in green, for the foreseeable future, especially in presence of that large sunspot. Here's the coronal hole field plot, and you can see the North Pole coronal hole dipping way down toward the equator here. And here's the line of sight field plot. Nothing too exciting happening there. Here's a view of the solar corona's magnetism. And keep in mind, it's a turbulent zone, a chaotic turbulent zone, the solar corona. Nothing to comment on there. Next, we'll talk about electrons, and we are seeing a forecast for a massive electron storm, and I would agree here. So currently, we don't see any real big charging hazards, just a little bit over places like Mexico and the Central Pacific. But check it out. Here's the one-year chart of the electron flux, and look at the forecast. These would be, I believe, the highest levels of electron flux we've seen in, I'm not even sure how long, but probably over 2 years would be my best guess without pouring through all the data. So we're right at electron flux warning levels here, which would be 1,000 pulse flux units as reported by NOAA. There's the 3-day chart of the electron flux, and we are expecting this to be way up into these areas in the next couple of days after that coronal hole wind stream subsides. So there are likely a lot of electrons chasing down that coronal hole wind stream, or perhaps being induced from the Earth. We really don't know, but we're expecting a lot of electrons in the Van Allen belt. Cheers. Here's a visualization of the total electron content forecast. And for you new viewers out there, this shows the whole air column all the way out to the thermosphere. And it's looking a little bit less anomalous here as they are focused into the normal regions. And this is typical of higher levels when the electron flux isn't cratered like it had been for about a week. Here is just one slice of the atmosphere. It's the F2 ionosphere map, courtesy of the Australian Government Bureau of Meteorology. Ionosphere is looking quite anomalous here. We're seeing major charge ups here over the nighttime portion of the planet. Here's the latest image. That one is coming in at 10:30 Universal Time. And it's looking normal at that moment. Next, we're going to look at volcanoes. Sakura-jima's erupting, producing an 8,000-foot ash plume. Suwanosei-jima, 4,000-foot ash plume there. Tokono's exploding, 7,000-foot ash plume there. White Island, ongoing ash emission in steam plume. North of New Zealand. Samisa-Pochnoi in the Aleutian Islands has issued an alert because eruptive activity. It's lowered the alert because no eruptive activity has been detected since mid-June. Nevado del Ruiz in Colombia, now erupting, exploding indeed, producing a 19,000-foot ash plume. Revenador, volcanic ash not detected, don't pole vault the caldera, and Sabancaya exploding, producing a 26,000-foot ash plume. And here at the Smash News Network, we would remind you that hang gliding over an ash plume of that size could be unfortunate for your health. Next, we'll have a look at earthquakes over the past 24 hours. No major quakes, although one in an odd spot up here in northern Canada. And let's go up the list, citing anything out of the ordinary. I think the largest of the past 24 may have been this 5.3 in Indonesia. There's a 4.5 deep quake in Afghanistan at 140.4 kilometers. Deep quake strikes Japan at 4.5 magnitude and 170 kilometers. And we're just going to scroll up the list here. A very shallow quake in California at 800 meters above sea level, followed only 5 minutes later by a deep quake at Argentina at 566 kilometers depth, one of the deepest we've ever reported on the South American continent. Here's where pressure cells are right now. According to windy.com, here's the GFS forecast for where they will be tomorrow at noon my time. And we've got some very concentrated low pressure zones here over the North Atlantic, as well as west of Alaska. Very concentrated low pressure cells there. And Alaska is actually surrounded by low pressure. And let's move on here. Once I get control of my system. By the way, windy.com has a fantastic mobile app. I use it on the regs. It's free, and you can download it from windy.com. And here is the nullschool.net animation of the jet streams of the eastern world. Check out the extreme bends down here. Western Australia, seeing a giant S forming in the 250 hectopascal wind currents. Here are the jets of the western world, I think. There we go. And the reason we show this daily is because this gives anybody in the world some insight into what may be going on above their head. It's part of the reason why we have the channel. Next, looking at lightningmaps.org. It's what I like to use when I hear thunder. And we got a major lightning storm off the east coast of the U.S. Check it out. Hey, Outer Banks. Hey, Nag's Head, there's thunder rolling in. Looks like a good day to be chilling with a wetsuit and a surfboard at the Outer Banks. Here's the lightning mapper. It's the GOES 16 lightning mapper. And I don't think it's loaded. We're just going to bypass that as I just showed you where it all is. Here's the U.S. Doppler radar map. And it's quite a significant storm there. It's essentially a nor'easter. And let's take a look at some closer images here. Here's what's going on in the cloud layer at the coast of North Carolina. Next, a water vapor map. It looks like we see some sudden cloud nucleation happening there. And check it out. This area of dry air looks like the Spitfire wheels. Looks like the Spitfire wheels mascot. Please leave a comment if you know what Spitfire wheels are. Yes. Spitfire wheels. Good stuff. And let's zoom in here around the Pennsylvania-Maryland border, just to give folks on the East Coast an idea of what that system's going to do next. And it may make a slight turn to the east here as that extra dry, cold air is pushed down over Lake Ontario and Lake Erie. Otherwise, a pretty stable flow happening there. And I'd like to thank everybody for tuning into the video. Thanks, Smash Team. Thanks, everybody, for flying American Smashways. Please keep your head and arms inside the Smash plane at all times because we've got the standard bonus of features. We're going to show you the colorized magnetogram of those crazy sunspot regions. And they are significant. And also, it looks like Sunspot 2783 has increased in its intensity here. It's now a beta class, so a significant uptick here in solar activity. A welcome sight after coming off of the second most significant solar minimum of our lifetimes. Of course, not as minimal as the solar minimum between cycle 23 and 24. And I don't care who got mad about that statement. Too bad. It's the facts. So there's Sunspot 2783, which is most assuredly now a beta class sunspot again. It has grown in size and intensity. And here you can see another beta class sunspot and another beta class sunspot. That's going to be named 2786 most assuredly. That would be my guess. So here's Sunspot 2783, and you can see it's turned into a beta class, increasing its propensity for flares, although probably not when it's in the Earth-facing zone, and I'm still not going to tell you what is causing the Earth-facing quiet effect. And there's that new group, and check out the size of this new sunspot. The umbra just about the size of the Earth. I think it's actually a little bit bigger. And I think Sunspot 2784 has completely evaporated. There's the full disk view, And here's the 193 angstroms view. Not a great view of the North Pole coronal hole right now, but this coronal hole is actually coming way down like this. There's just a bunch of plasma out there. And again, there is a significant possibility for coronal mass ejections. There is a bunch of plasma in between the Earth and the Sun right now, and it's primarily right around where that sunspot group is in the southeast. Thanks for tuning in. Remember, stare at the sun, don't drink it. If you do, don't drive. Welcome to the Neo Renaissance. Stare at the sun, don't drink. Attempt to understand the physics. May that solar wind be at your back, and that fraud absent from your YouTube subscriptions feed.